Yeah, read this question.
The wind is blowing from south at 10 meters per second, but to a cyclist it appears blowing from the east at 10 meters per second. The velocity of cyclist is.
So, whenever the information is given related to east, west, north, south, first draw like that. East, west, north, south. In the question, we found that they told the first line, the wind is blowing from south at 10 meters per second. So, wind is blowing from south at 10 meters per second. That indicates that it is blowing towards the north. So wind is blowing from south at 10 meters per second. Fine. But to a cyclist, it appears from the east at 10 meters per second. So cyclist is observing the wind. So for cyclist, what he felt here is, he felt that wind is blowing from east. Wind is blowing from east. It appears means it is not real. He is feeling that one. To cyclist, it appears blowing from east. That means coming from east towards the west. Appears. That is nothing but I can treat it as relative velocity. The feeling of the person and those stuff we can call it as relative velocity. V suffix R indicates relative velocity, and that is also given as 10 meters per second. Now they're asking what is the velocity of cyclist? Velocity of cyclist. So my target is to find velocity of cyclist. So cyclist is traveling with some speed and observing. Suppose what I want to say here is cyclist is rest, is not cycling, just on the cycle he is rest and observing. Then what will happen? Wind velocity is in north direction means it will be blowing north only, no doubt. For him also it appears blowing north only. But wind is blowing north, but cyclist it is appearing towards west means cyclist is not at rest. Cyclist is moving with some velocity in some particular direction. In which direction cyclist is moving and those stuff we don't know. So for that purpose, we know one thing, it appears, that is called as relative velocity. So what can I write here? Relative velocity means, first of all, the velocity of one with respect to another. Relative velocity of one with respect to another. My question is, among wind and cyclist, who is observer? Wind will observe cyclist or cycle will still observe wind? Who will observe whom? Cyclist will observe wind or wind will observe cyclist? Who is observer among? Cyclist is observer, right?
Yes, sir.
Yes. Generally, beta, think like a human being. Wind and cyclist are there. If wind is observing the cyclist means we'll think that is some devil is there. So cyclist will be observing the wind, right? So observer is cyclist. My simple technique for relative velocity problems is simple technique. Observer must be subtracted. Observer must be subtracted. That is cyclist is observer. So observer that is minus VC bar. Write it as VW bar minus VC bar. Because you know that whenever we speak about relative velocity, V12 bar means V1 bar minus V2 bar. V21 bar means V2 bar minus V1 bar. That is a 1 with respect to 2, 2 with respect to 1. Velocity, relative velocity concepts will write the formula here. What I mean to say, always the subtracting velocity is the observer velocity. Observer velocity. So observer is subtracted. If you keep that thing in mind, the direction confusion will be erased. So here cyclist and wind is not observer, cyclist is observer. So relative velocity I wrote like that. Now they're asking me to find VC bar. So VC bar, if I take that side, I can write VW bar minus VR bar. So VC bar, I can also write it as now VW bar plus minus VR bar. Very simple. I didn't do anything here. I have got first cyclist expression. First I have did with nothing here. V cyclist that side and relative velocity in this direction. So when I shuffle the terms here, VC bar equal to VW bar minus VR bar I got. Very simple here. After that, VC bar is equal to VW bar plus minus VR bar. So the VC bar lies between VW bar and minus VR bar. So initially VR is taken in this direction. In this direction it is plus VR, means in opposite direction what will happen here, if you take VR bar in this direction, minus VR bar will be in opposite direction. Minus VR bar will be in opposite direction. Here VW is equal to 10 meter per second. That is the VW bar is in this direction. Minus VR bar is in this direction. Why you are taking like that, sir? Because cyclist velocity is a resultant of VW bar and the minus VR bar. Resultant in parallelogram law of acceleration, we studied that resultant always lies in between them. So I get the resultant like this. This is the resultant. There's a VW bar plus minus VR bar. Resultant is VC bar. VC bar, cyclist velocity is in this direction. So this is the first step what I got here. So finally I got VC bar direction is I can observe it is lying somewhere in between north and east. North and east. So let me again take the diagram here. What I did here, first of all, I have made two lines like that, and here this is what I told north and this is east, and I got VC bar in this direction. I know here the value is VR bar minus VR bar or anything. Value is 10 meter per second. Here also VW, that is a V wind value is 10 meter per second. VR value is 10 meter per second. Value is same. We know that in parallelogram law of vector addition, when we happen these two are equal values, the resultant will be exactly on bisector. Theta is 45. So theta is 45 here and it is in this direction. We know when they are perpendicular to each other, we heard that VW bar plus square plus VR square, V relative square. We will write it as V relative square here. From this information, I can write square root of 10 square plus 10 square. There's nothing but 10 root 2 meter per second. Exactly at bisector. So here this is north, this is east. Exactly in between north and east means northeast. Is it clear, beta?
Yes, sir.
So my answer is 10 root 2 meter per second towards northeast. Cyclist is traveling in that direction. Here this is a VR value is 10 means even minus VR value also what will happen, this also will be 10 only. So both are 10 and 10 perpendicular. So equal values means it will be exactly on bisector 45 degree, and perpendicular means we are writing 10 square plus 10 square. There is nothing but 10 root 2, 10 root 2, 45. Exactly between north and east, we call it as northeast. Like that, we can solve this problem related to cyclist velocity finding by help of relative velocity topic. Is it clear?
Yes, sir.
Fine. So you understood this one in this way, something you got idea about in this method. Now I want to do this one in different method. I want to do in another method. I don't want to take the diagram help that much. Little help only I need from diagram. Then how to do in another way? Let me check it out. So just see here. One problem here, the same problem I'm taking in different method I want to solve. First of all, we are very clear that wind is blowing from south. That is the VW is equal to 10. And again, we know that it appears relative velocity that is also 10 meter per second. We know that VR bar as usual, VW bar minus VC bar, same information what we gathered here. But one thing you remember, this is the north, this is the east, this is the west, south. East I am taking it as I cap. North I am taking it as J cap. West I am taking it as minus I cap. South I am taking it as minus J cap. So now what should I write here? I write here VC bar is VW bar minus VR bar. Here VW bar means, first of all, what is the VW value here? VW value is 10. So I can write it as 10 into which direction it is? J cap. And what about VR bar? VR bar it is also 10. But which direction? West. West is nothing but minus I cap. So let us substitute these two stuff in the above VC bar formula. VC bar formula, VW bar 10 J cap minus of 10 into minus I cap. So what we can write here, minus of minus plus. So I can write it as 10 J cap plus 10 I cap. This is the value of VC bar. This is one method of solving. So I got VC bar value now. So VC bar, if I know, what should I do now? So VC bar value just now I wrote it as 10 J cap plus 10 I cap. So I can write it as VC bar is equal to 10 I cap plus 10 J cap. From here, what is the magnitude we know from two-dimensional vector? Simply 10 square plus 10 square is equal to what I can write 10 root 2. And we know that tan theta means y component, which suppose with respect to x-axis means y component by x component 1. Oppose that is the y component, the j component by I component, or y component by x component is 1. From here I can write theta is equal to 45 degree. And one more thing here I observed, this is I cap, this is J cap, and this is theta is 45 plus I cap plus J cap, theta is 45. So I cap indicates east, J cap indicates north, 45 means exact between northeast. So my answer is 10 root 2 northeast. Is it clear, kids?
Yes, sir.
Yes, sir.
So this is one more method to solve in terms of I cap and J cap. And one more, what we did here, very simple. First, we have taken wind velocity in which direction means it is a J cap. Again, relative velocity in which direction means minus I cap. So I have taken general formula, relative velocity is wind velocity minus cyclist velocity. I want cyclist velocity as usual. I substituted the value of VW bar. VW bar means 10 J cap. VR bar minus 10 I cap. When I substituted these two stuff in this formula, what happened here? Finally, I got 10 J cap plus 10 I cap. Immediately, what I did here after getting this one VC bar value when it is known. So 10 I cap plus 10 J cap. Magnitude of a vector, square root of 10 square plus 10 square, 10 root 2. And what is tan theta here? Tan theta is y component by x component dot j component by I component 1. Theta indicates 45 degree. 45 degree means exactly in between. No doubt here you can observe I cap positive, J cap positive. I cap positive, J cap positive means first quadrant. First quadrant, theta 45. First quadrant means north and east. exactly between northeast. So finally I got northeast. That is how to solve the problems related to relative velocity. These are the two methods, both I explained you. I hope you are clear here.